Greetings. Welcome to the HBCU STEM Undergraduate Success Research Center. Today we are going to be learning how laboratory courses with guided inquiry modules improve scientific reasoning and experimental design skills for the least prepared undergraduates by Lawrence S. Bloomer and Christopher W. Beck. Now let's get some background information on the topic. Efforts to transform undergraduate education, including laboratory pedagogy, have been pursued for more than 2 decades. The effects of inquiry-based learning have been inconsistent across various STEM disciplines and levels, and because of this, researchers and scientists are still trying to decide who benefits the most from this form of learning. There are several confounding variables that may contribute to these conflicting results, which include gender, race, age, and first-generation status. There have been attempts to control for these variables, but the research still renders differing results. Now let's look at what researchers wanted to discover within this study. The purpose of this study was to examine whether students with different levels of prior preparation responded differently to laboratory courses that included a guided inquiry module using the bean beetle model. And now we will learn about the methods used to conduct this research. Data was collected for 4 years across 12 different institutions and from 51 different courses for a total of 570 student participants. After cleaning the data for any responses that may encourage a bias, the final data set included 11 institutions, 33 courses, and 479 student participants. After reviewing previous work, and in order to further examine the impact of the guided inquiry module, the researchers felt it was best to divide the student participants into 4 groups based on their pre-test scores. Group 1 represented the highest level of students, meaning these students scored the highest on the pre-test, all the way to Group 4, which represents the lowest level of students, meaning these students scored the lowest on the pre-test. In the case of this study, a lower pre-test represents lower prior preparation. This was a 4-year project that included 2 studies. For the first 2 years, Study 1 was conducted, and for the last 2 years, Study 2 was conducted. Study 1 looked at the impact on scientific reasoning skills, and Study 2 looked at experimental design skills. After data was collected from the pre- and post-test, all statistical analyses were conducted using SPSS statistics. Now let's move into the results. Overall, Study 1 nor Study 2 showed a significant increase from pre-test to post-test. For Study 1, absolute gains were significantly negatively related to pretest score, meaning that students with a higher pretest score showed lower gains. Also, course level did not have a significant impact when observed independently by groups. For Study 2, basic understanding, advanced understanding, and composite score on the EDAT did not increase significantly, in that students with higher pretest scores also showed lower gains. When examining the post-test scores, all groups showed significant differences. The lowest level group showed significant gains for basic understanding, advanced understanding, and composite score. When examining every other group, the results vary based on pretest score. For example, students in Group 3 showed no significant change from the beginning of the semester to the end of the semester in experimental design, composite score, basic understanding, and advanced understanding. Course level had no effect on student scores, which resulted in students in introductory courses having greater gains compared with students in upper level courses independent of the pretest scores. Yet, this work did support the idea that students with different level of prior preparation respond differently to courses that include a guided inquiry module. Let's discuss what was discovered. Despite previous research that students exhibit significant learning gains when they take inquiry-based laboratory courses, this study found no significant gains in students' scientific reasoning and experimental design skills in guided inquiry laboratory courses across a broad range of course levels and institutions. However, the study did show that laboratory courses should use guided inquiry modules because of the positive gains in scientific reasoning and experimental design skills for the least prepared students. These students benefited the most from the Bean Beetle project, and similar projects should be considered when working with this demographic of student. It should be noted that the project did not close the gap between these students in the highest group and those in the lowest group, but it is still very much worth it for those in the lowest group. The researchers believe the students in the highest group may have encountered the ceiling effect. Therefore, a future project may want to think of more challenging ways to stimulate these students within the module. Due to the researchers not being able to control student motivation to complete the module, this may have affected the scores of students in the highest group as well. Future researchers should examine courses at different levels at the same institution and examine the impact of interventions for students in the four scoring groups differently. Thank you for learning how laboratory courses with guided inquiry modules improve scientific reasoning and experimental design skills for the least prepared undergraduates by Lawrence S. Bloomer and Christopher W. Beck. We hope you will share what you learned here today and come back to learn more.